introductory kind of silly question in a bit. But this is, oh, here's Alex. This is Unit 2, Lesson 4. First thing, as usual, is to go find the tasks to complete list. You can find it either under assignments or on the Science2 Canvas homepage under the weekly calendar. Today's date is the 26th. So you're looking for tasks for U2L4. First thing we'll do is our little breakout room chat. Kind of a bigger question this time around, but the question is, what's the best piece of advice you have ever been given? You guys haven't answered this yet, have you? No, okay. So this doesn't have to be like profound, life-changing. Next thing was to review the homework. The only homework was the bottle spin and bottle flip and water spin activity Flipgrid. I'm seeing 13 responses on Flipgrid, which is great. If you haven't posted a video yet, please do so. Hopefully you didn't spill water all over the place. So I've seen some pretty entertaining videos with people sending water all over. You then had to do the PhET simulation where you were entering certain numbers, and then the reading quiz for Hewitt 5.9 through 5.11. All of those look great. Seeing 14 responses on each. Don't worry if it like marked you wrong on a certain question, the Canvas quiz, because I have it auto grading, but the auto grader doesn't compensate for maybe certain differences in angle. So I'll go through and manually fix things afterwards. So don't panic if it like marked you wrong for some reason. But were there any questions or comments on those assignments? All right. We're going to do very similar stuff today, but we're going to add in the wrinkle now of drag and how that affects altitude and range. And same thing, we'll do a little kind of Flipgrid activity, and you'll be working with the same PhET simulation, but with a little more detail this time. So next task was an ed puzzle. I wanted to touch on a little bit of biology, and this is kind of follow up on that homework assignment because the last question was looking at human evolution and why we're so good at throwing. And so this is task number 3. There's an ed puzzle. It's about 4.5 minutes long with 4 questions. I'm going to time for 10 minutes to work through it. Hopefully it won't take 10 minutes to complete, and I can watch as people complete it. So once most of you have it done, I will bring us back together. If ed puzzle doesn't work for you, there is a link to the original video right underneath as well. It's that bullet point right there. Here's the original video. So 10 minutes to work on that ed puzzle, how throwing made us human. Let me know if you have questions. Go for it. Is what orbit is, right? Orbit is the fact that if you were to do that, you could theoretically hit yourself in the back of the head, right? I like this kind of diagram here. And that's essentially what orbit is, right? It's falling around the planet, right? It falls 5 meters for every 1 second, but it's also going 8 kilometers forward. And so theoretically, a projectile moving like that would hover right over the surface of the planet. Now, that's impossible though, because we have atmosphere on Earth's surface. So if you really wanted to do this, you have to get outside the atmosphere, because otherwise you're always going to have air drag. And something going 8 kilometers per second, that's 18,000 miles per hour. Anything going that fast would burn up in our atmosphere very, very quickly. And so in order to launch satellites and things like that, or space shuttles, we have to get them 150 kilometers up off the ground. And at that point, you're technically outside of Earth's atmosphere, or at least there's not nearly as much gas to cause drag or friction. And so that's where you can have orbit occur. So this is why it takes so much fuel to launch things into space, because we have to get them 150 kilometers up, and we have to get them going at least 18,000 miles per hour in order to continuously fall around our planet. But that's essentially what that is, right? Satellites orbiting at high altitudes are not under lower gravity. Please keep that in mind, right? Again, erase this idea that there's lower gravity in space. That's not true. Especially when you're orbiting around Earth, you're experiencing pretty much at least 90% of the gravity that you would have experienced on the surface. It's just that they're falling around the planet rather than straight down. I had an animation here ready to go. I don't think I've got it open. Oh, let's try. If I have the slides open on here, then I think I can. Let me share my screen here real quick. It's just kind of a helpful video for visualizing this. It's an ed puzzle. It's short though, it's 30 seconds. So, all right, here we go. Let's see if this will open. Awesome. So I think this kind of helps you kind of understand what's going on with this projectile. So it's going to show you launching a projectile until it finally kind of achieves orbit.
Here's an easy animation showing how something like a satellite or the moon orbits Earth. At just the right trajectory and velocity, it's possible to make an object fall basically forever.
So everyone see that it kind of had all these failed attempts, but then you finally hit that point where you have enough horizontal velocity and vertical velocity matching to match the curvature of whatever your planet is. That's what orbit is. Questions or comments on that? All right, let's do 2 activities today to explore this. The first one you're going to do is on the tasks to complete list, step number 5, I believe. Yeah, this is called the how far can you throw Flipgrid. This one's a little more involved than ones you've done in the past. You might notice that it's actually a quiz instead of just an assignment where you're going to be uploading a video, though you should be uploading a video to Flipgrid as part of this. But I have instructions in the quiz. I have a demonstration video like always, but essentially you're going to be taking 2 socks, one that is not balled up and one that is balled up. You're gonna be throwing it as far as you can. So get outside or get in a hallway or somewhere where you can do that safely. Please avoid glass statues and fire sprinklers and things like that. And you're gonna be measuring how far you can throw and just comparing them. So you can just use your feet, kind of walk heel toe, like what we did when we did the walking the solar system thing, but that will, the demonstration video will show that. So, and then if you've managed to finish that, you are welcome to then move on to step 6, which is the PhET simulation, very similar to what we did last time, where you'll just be using that PhET simulation to answer some questions. So I'm gonna go ahead and time for 15 minutes to get you going on this. And then regardless of whether you're done or not, we'll just come back together to check in, and then I'll let you go for whatever time we have remaining to keep working on stuff. So 15 minutes, I'm here to answer questions if you got any, go for it.